So now we're going to talk about percentages, calculating percentages in a contingency table. You have three different types of percentages to calculate. Now these are just essentially relative frequencies. So again, in contingency tables, we have absolute frequencies, which are common, and here we have data from the Titanic, which I'll discuss in a minute. Absolute frequencies are only useful to an extent, and that extent is really just telling the sheer numbers of people you have in each category. But to really understand the relationship between two variables, you really do need relative frequencies. So in order to calculate a relative frequency, there are three different types. You can do a percent of grand total, a percent of the column total, or a percent of the row total. So in order to calculate the percent of the grand total, and here the 1300 again is the grand total, and these are marginal totals here. That's 350, 450, 400, and 100. And here I have 500 and 800. The percent of the grand total is simply taking one of the cells of the data themselves, not the marginal totals, but the data that you've actually cross-tabulated, and dividing it over the grand total, which in this case is 1300. So for example, 75 in this first cell over 1300, and that gives you 5.8%. So these data are taken from the Titanic data set, meaning these are actually data taken directly from the manifesto for the Titanic when the Titanic sank. And we have, and I've slightly manipulated the data, only slightly to show emphasis in some categories. Okay, so here I have age groups. I have 0 to 19, 20 to 39, 40 to 59, and 60 or over. So this is the age groups of all the passengers in the Titanic. If you notice a couple of things about the age groups, one, they are mutually exclusive groups, meaning that someone who is 19 can only fall into one group, or someone who is 39 can only land here. Mutually exclusive means that each category of age is independent from the other. It's not, there's nothing in that, no one in that group can fall into more than one group. Okay? So if this was 40 to 60 and this was 60 and over, we would not have a mutually exclusive group because 60-year-old could fall here and here. So that's one thing I wanted to point out. The next thing I wanted to point out is that they're actually collectively exhaustive. And what that means is that every person's possible age is found in at least one of the categories. So if you're 0 years old, you're going to fall in here. And if you are 69, you're going to fall in this last category. So, and if you're 41, you'll be in this category. The point is that everybody's age will be represented in at least in one of the categories. And then the last thing I wanted to point out about the age categories is that the age categories are equally distributed. Not equally distributed, that's necessarily the right word. The age groups contain the same number of ages. So for example, 0 to 19 is 20 total ages, right? 20 to 39 is 20 total ages. 40 to 59 is 20 total ages, and 60 and over is not, but that's because it can go up to a very large number. So, but generally you want to make your age groups equidistant. And then I have survival, yes, and survival, no. So, and that's self-explanatory, but this basically is a variable describing whether they actually survived the sinking of the Titanic or not. And the total number of people who survived was 500. The total number of people who did not survive was 800. Total passengers, 1,300. Okay? So if I said, what is the percent of grand total for passengers 0 to 19 and survived, you would give me the answer 5.8%, which is 75 divided by 1,300. So the percent of the grand total, this is the grand total, of passengers in the age group 0 to 19 and survived, where those two cells meet, those two rows or columns meet, is 75. So it's 75 out of 1,300, that's 5.8%. So is that interesting? Mm, to me, it's not that interesting. I don't know. It's not. It's not telling you exactly the nature of the two variables, which is age groups and survived. We don't know how more or less likely that age group was compared to other age groups using the percent of grand total. So the percent of grand total is probably the least useful of the three types of percentages. The next percentage I have an example of is percent of column total. So again, using 0 to 19 age group and survived, which is 75 people, the percent of column total is 75 out of 500. And it's 500 because this is the column total, 500. So 75 divided by 500. So now I have 15% who were 0 to 19 and survived. Is that interesting? I think it might be. We'll know more when we do all of the percentages. And then the percent of the row total is simply the 75 divided by 350. And this is the row total. Again, it's a marginal here. This is marginal totaling across these two columns, 350. So it's 75 divided by the row total, which is 350. So if your row percentages are added up across columns, they should add up to 100%. So this 21.4 plus 78.6 should add up to 100%. Again, that's a row percentage. It's a row percentage because I did 75 divided by 350 and 275 divided by 350, and I got these percentages. 200 divided by 450 is 44.4. 250 divided by 450 is 55.6. 200 divided by 400, as you know, is 50%. 200 divided by 400, again, is 50%. And 25 out of 100 is 25%, and 75 out of 100 is 75%. So if we did this correctly, your percentages here and here should add up to 100%. So this table here is giving you an example of a row percentage. Now, a row percentage is most useful for telling the relationship between two variables, and again, in this case, it's age group and survival, if the dependent variable, or the outcome variable, is the column. And they're often seen both ways. Dependent variables can be seen in the columns, or they can be seen in the rows. From my perspective, you'll often see them in the columns, at least in the health and social sciences world, although it can be seen both ways, absolutely. So you just have to be aware of what your research question is and what your actual outcome variable is. And in this case, survival is almost always an outcome. So I have it up here at the top. Now, if you did a column percentage, it should also add up, but it should add up this way to 100%. And of course, we didn't do column percent, we did a row percent here. But if we did a column percent, this row, or this percentage, this percentage, this percentage, and this percentage would all add up to 100%. And that 75 would be out of 500, 200 would be out of 500, 200 out of 500, and 25 out of 500. And those percentages would add up to 100%. So which age group had the highest rate of death? Well, let's look at the rates of the death, okay? So survival, no, not survived is death, right? So the age group with the highest percentage is 0 to 19, because they had 78.6%, and greater than 60, or 60 and over, 75%. So 78.6% of the people in the 0 to 19 age group died. That is astonishing, 78.6%. And 75% of anybody 60 or over died. That's a lot of people. And the lowest percentage of death was in the 40 to 59, where only 50 people died. 50% of the people died. And in the 20 to 39 age group, 55.6% of the people died, which is 250 out of 450. So the highest percentages, not really all that surprising, were found in the youngest and in the oldest. So based off of that, do you agree that rates of survival depend on age? And in other words, do you think that survival percentage, percentage of people who actually survived, changes by age category? Is it dependent on age? So looking at the data the way they are at this point, your answer should be yes. Because if you look at their survival or even lack of survival, in other words, death, 78.6% is quite a lot different than 50%, right? 21.4% is quite a different than 44% or 50%. So in order to actually see whether there's a relationship, you will actually start comparing these percentages to one another, and we'll discuss on how to do that next. But if you do think there is a relationship between survival and age, do you think that relationship is a correlation or an actual causal effect? So do you think that there could be another variable explaining why the oldest and the youngest died? Or do you think it's simply a nature of their age, that the cold waters were easier to survive if you were in the middle age ranges, but if you're the youngest or the oldest, it was much harder to survive? So we'll talk about potential reasons for those differences in the ages in a minute. But I wanted to bring up a couple of small sort of editorial issues. One, when you create your percentages, you want to make sure you round up. So if you notice here, I have 74.55%. You really should make that 74.6, just because you could make this percentage go on and on and on and on. And just to make it clean, just make it round up one decimal. And also just use one decimal. In other words, 78.6. Don't use two decimals. And also, when you're describing a table, in the text, when you're writing up your report saying, okay, in table 2 we have this percentage of people who died, make sure that you're using the same decimals in the text as you would in the table. So again, going back to the table that we just did before, looking at ages and survival, I asked if we thought there was a relationship between age and survival. Well, if we're looking at row percentages, if you look at row percentages, if there's no relationship between age and survival, then these percentages should be the same all the way down. In other words, the same percentage of people in the 0 to 19 group survived as the percentage of people who survived in the 20 to 39, as did in the percentage of people who survived in the 40 to 59, as did the same percentage of people who survived in the 60 to or over. In other words, you're not more likely or less likely to survive if you're in a 0 to 19, 20 to 39, 40 to 59, or 60 or over. But that's not what we see. We actually see, as I discussed earlier, that the highest percentages of death are actually in the 0 to 19, or the lowest percentages of survival are in the 0 to 19, and the next lowest is in the 60 or over. So 21.4 does not equal 44, does not equal 50, and does not equal 25. And 44 does not equal 50, and 50 does not equal 25. In other words, across all four of these rows, down this column of survival, they are not equal. And if they are not equal, using row percentages, then we have an association. We have an association between these two variables. One variable is, in fact, dependent on the other. So I asked if there was a relationship between age and survival, if this was a causal relationship, or if this relationship was simply a correlation or association. So one thing you always have to consider is a third factor. There's potentially a third factor going on. And here I've actually looked at one of those third factors. This isn't looking at survival. This is simply looking at the passenger class. So here we have third class, second class, and first class. And we see here across, I have row percentages. You see here that the majority of the passengers in the 0 to 19 age group were found in the second class. And the majority were found in the second class in the 20 to 39. And the majority were found in the second class in the 60 or over. That's all fine. Not the majority, I should say, for the 40 to 59 or the 20 to 39. I'm sorry, that's sort of the plurality. But the largest percentage of people in that group, in that age group, were found in the second class. So second class is the most commonly found passenger class. That's fine. But if you look at the first class, if there was no relationship between passenger class and age group, then these percentages going down each column would be the same. Again, it's the same reason with survival. If there's a relationship between this variable, passenger class, and age group, then row percentages should be the same going down a column, because that basically is saying that the percentage of people in this 0 to 19 age group who are in the first class is the same as the percentage of people in this 20 to 39 age group in the first class. Okay? But we see that that's not the case. Only 14% of those in the 0 to 19 were in the first class. And only 25% in the 60 or over were in the first class. Whereas 37.5% of the 40 to 59 were found in the first class. Now that's that's like 2.5 times more passengers in the 40 to 59 group were found in the first class as were found in the 0 to 19 age group in the first class. So qualitatively, comparing age group and passenger class, there is a relationship, and that relationship is seen through the percentages going down a column if we have row percent, going down a column if the percentages are not the same. And again, they are not the same, so we assume that they are related. So perhaps the relationship we saw between age group and survival is not a causal effect relationship. Perhaps it's really just a relationship that is seen through passenger class. That is to say, maybe those who are in first class were more likely to survive than those who are in third class, maybe due to class itself or access to lifeboats or something along those lines.